Yeah, on the right hand side, everything like related to part one, we have already proved that. We have also we just made the list of everything, like what will be the, according to CPCT, what will be the corresponding side, corresponding angle, why we did so, so that maybe it will be helpful for the second and third and fourth part. So first part we have already done. We are going to start from second part. Yeah, second part also we have discussed already. We just need to list down everything over here. So second part, as you can see, let me show you the figure. We are talking about triangle ABP and triangle ACP. So already we have done the discussion regarding these two triangle, and we know in triangle ABP and triangle ACP, AB is equals to AC. From where am I writing this one? It's already given. What's the next thing? The next thing is angle A over here is equals to angle A over there. From where we are getting that? We got that from this part. Yeah, this one. Okay. That angle A, BAD is equals to CAD. So that one also we can use over here. Let's use that. So I want to write here that angle BAP is equals to angle CAP. Yeah. From the proof of first part. And the next one is AP and AP are common in both the triangles. So we got the sequence. That side, you can see sequence is already written over here because we have discussed this part in the previous class. Side angle, side sequence is maintained over here. So we can say that triangle ABP is congruent with triangle ACP by side angle side congruency rule. Now we are done with part 2. Okay, here now once we will focus on part 3. It says AP bisect angle A as well as angle D. Here we already know that AP is bisecting angle A because this angle A and that angle A is already same. So obviously AC is bisecting angle A, right? So
Yes,
we
ma'am.
can say AP is bisecting angle A. Yes or no? We already know that this angle, let me show you. We already know that this angle, this yellow one and that yellow one, both are same. So we can say, yes, AP is bisecting angle A. Yes or no? Are you getting it?
Yes, ma'am.
So since we already know, from where we know this? We know this from part A only. You can see here the yellow rectangular box, that angle BAD is equals to angle CAD. Angle BAD, this was D. Angle BAD, angle CAD, both are same. We know this from part 1 proof only. So we can say, yes, AP is bisecting angle A. Okay. So here we'll be writing, yeah, since angle BAD is equals to angle CAD, from part 1 we have got that. Therefore, AP is bisecting these two angles are already same. From here also, from the second part proof also, we can say angle A over here is equals to angle A over there. So any proof you can use to clarify that. By using this proof, we can say AP is bisecting angle. Now the next, part is talking about it is bisecting angle D as well. Okay, here we are having angle D over here. D, this is D. So we also have to prove that it is bisecting angle D. How we will say that it is bisecting angle D? Still we don't know anything about D. Okay, so we have to take the triangle BDP and triangle CDP to prove that. We wanna take, let me show you which two triangle I'm talking about. We have to take this triangle, this one, this triangle, the orange one, and we have to take that triangle. Okay, this one, this orange one and the lavender one, both the triangle we have to take to prove that these two triangle are congruent with each other. Then and only then we'll be able to say that angle D is getting bisected, because this side D and that side D both are exactly same by CPCT. So once we'll be able to say that, then we can say that okay, D is also getting bisected. So part 3 is asking AP bisect angle A as well as angle D. AP is bisecting angle A. We have already got it from part 1, okay, or you can say part 2 also. But what about D? For that, again, we have to prove one more congruency. So if we will focus on triangle BDP and triangle CDP, let's write it in triangle BDP and triangle CDP. What we know already, we know that BD is equals to CD. Here it's given already. BD and CD are same. Let's write it. BD from here, CD from there. What's the next thing we already know? Here we know this one and that one. We also know, do we know BPPC? BPC, yeah. Can you see from part 2 proof, we know that BP and CP are corresponding part of congruent triangle. Can you see, everyone, can you see the circled part? Can you see? Everyone, are you there?
Yes, ma'am.
Can I write BP is equals to CP? Can you see this circled part? This one and this one? This one and this one?
Yes, ma'am.
So I want to use that because congruency there we have proved. So that BP is equals to CP we are using. Please don't get confused. We are just completing the previous day's question. Okay. So that's why I have started from the middle only. So if it is not getting clear, then everything is here only. We will just get back to it. So I want to write here BP is equals to CP. That too we know. And what about the third information? The third information is angle this total B and this total C are same. We know that blue, this is X and this is also X. That blue, this blue is same. So if total are same, one of the part of that one, the total, one of the part of that total is also same, then we can say remaining will also be same, right? So I want to write that angle. Here we are having one triangle. Okay. Here this total is equals to this total. We already know that is angle AB A B C P. Okay, that's not P, that's D. This is D and this is P. I am saying that we already know that ABP is equals to angle ACP. Total angles are same. And we also know that much, this much and this much are same. So we also know that angle ABD is equals to angle ACD. Now, if this is equation number 1, this is equation number 2, and if you will subtract both the equation, left hand side, we are going to subtract left hand side. From right hand side, we'll be subtracting right hand side. This is how we subtract two equation. When you are having two equation, and if you want to do the addition, subtraction, then you can do addition of left hand side with left hand side, right hand side with right hand side, and that is allowed because Euclid said that if two things are already equal, and if you are adding something which is equal or subtracting something which is equal already, then you are again, whatever you are going to get, that will remain equal with each other. So I am having ABP is equals to ACP. From here I am going to subtract something which are already equal, that is ABD minus ACD. So basically we are subtracting equation 2 from equation 1. Once you will look at the picture, from the total red angle, I am subtracting the green part. So we will be left with this sky part, this much. Okay, so we can say that angle DBP is equals to angle DCP. Okay, yeah. So this is what we got it from here. We are having two information over here and one information over here. Let's mark it in the triangle to check what exactly we got. So we have used this side. We have used this side. Okay, without doing this much of hassle, we could have proved that this two are, no need to take this much. Okay, we can take dp is equals to dp, and side congruency rule we can easily apply without this much of angle subtraction and all right. Can you see in both the triangle all the sides are equal with each other? Just that. Can you see it, that dp is equals to dp common side, and hence we can say that these two triangles are congruent with each other. Why we are so focused on proving this triangle, that triangle? Because we want to say that D is bisecting, DP is bisecting angle D as well. So once we will say that triangle BDP is congruent with triangle CDP by side congruency rule, then we can say that angle D over here is equals to angle D over there. Okay, so we can say therefore angle BDP must be equals to angle CTP by CPCT, and hence angle D is getting bisected. Okay, that's what we needed. We have to prove it. Yeah, AP is bisected by AP or DP, whatever you say. Okay, Now fourth part is there, AP is perpendicular bisector of BC. Here only we can say AP is perpendicular bisector because we know that this angle P is equals to that angle P. We already know that since just by the congruency of this two, we can say that angle BPD is equals to angle CPD. Okay, from by CPCT only. And we know that sum of BPD plus CPD will be 180 degree because it's making a linear pair. And from here we will get, since both are same, so both are same, let's say both are x. So this is x is equals to 180. That means twice x is equals to 180 and x is equals to 90 degree. What we wanted to prove, that AP is the perpendicular bisector. So yeah, AP is, you can see the figure, AP is perpendicular bisector. Okay, is it bisector? Yes, it's a bisector because BPCP already we have got same in one of the congruency part. So this is how we are done with the first question. Okay, this was the total explanation. Just sit with this question and try it by yourself. You will be able to do it. Okay, if you are getting confused since we started from the middle of any of the part, so please do it by yourself. If you will again not be able to finish it, then we'll be discussing it again. Okay, let's take number 2. First try it, okay, and then do let me know whether it's clear or not, because maybe by looking at the board you are not so sure or whatever. So first try it and then do let me know whether you have done it or not. I'm taking question number 2 from here freshly so that you can understand what exactly going on. Everybody, today we are going to finish this triangle chapter. So just give me a second. Yeah, let's take the next question. Question number 2. AD is an altitude of an isosceles triangle ABC. We are having an isosceles triangle ABC. A, B, C, where AD is an altitude, in which it's given that AB is equals to AC. Show that, it's written that, show that AD bisect BC. This is the first part which we need to prove here. And the second part is AD bisect angle A. Okay, these are the two parts which we have to prove over here. It says that ABC is an isosceles triangle. Obviously, it's given that AB is equals to AC. And it's also written in the question itself that AD is the altitude. What's the meaning of altitude? That it will be perpendicular. Okay, that's how we will be taking the altitude. Whenever altitude word is mentioned, we'll be taking, it's making 90 degree with the other side. Whenever it's mentioned that yeah, one is altitude, another is when we'll be doing the next question, we'll be talking about that. Let me check what's that. So here we have to show the first part, that is AD bisect BC. Okay, so we have to show that this BC is getting bisected. That means BD is equals to DC. That's what we have to prove here. Given that AB is equals to AC. angle ADB is equals to angle ADC is equals to 90 degree. These two information are given over here. And to prove that BD is equals to DC, that's how we'll be able to say that side BC is getting bisected. Okay, getting cutted in two equal parts. So how we will do so? We can take triangle ABD and triangle ACD. I'm talking about the sky triangle and this triangle. And we will see whether it's possible to prove this two as a congruent or not. So in a sky triangle, let's take this two triangle. In triangle ABD and triangle ACD, what we know already, we know that AB from here is equals to AC from here. From where? It's given. We also know 90 degree, 90 degree. So let's write it. We know that ADB from here is equals to ADC from there. That is 90 degree and that too is given. Okay. What is the next information? Here, can we say AD is equals to AD, common side? Yes, we can say that. But is it going to help us to prove this two triangle as a congruent? So we have used this side. We have used this side. And we have used this 90 degree. Okay. So 90 degree means right angle. This side is hypotenuse. And this side is just a side. So can I say RHS congruency rule can help us to say that these two triangles are congruent with each other? Can we? Is there any RHS congruency rule? Anyone?
Yes, ma'am, it's there.
It's there. Obviously, it's there. So we can say that by right angle, RHS congruency rule, what does it says? Right angle, hypotenuse, and one of the side. So we are going to write that triangle ABD is congruent with triangle ACD by RHS congruency rule. If you don't know what exactly is RHS congruency rule, again I'm reminding, RHS means right angle, hypotenuse, and one of the side. If this is the sequence you are getting, then there is a rule for that. That is RHS congruency rule. Till now we are having congruency rule side, 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 side angle, side, angle, side, angle, 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 side, and RHS. These are the list of rules we are having, and from here only we are picking the rule according to our whatever we have, according to the list, according to the information. So we have proved that this triangle, the sky one, is congruent with the lavender one. Now here we can say that since these two are congruent, so obviously from here only I can see BD and CD are same. BD is equals to CD. And that's what we needed to prove for part 1, that AD is bisecting BC. So if BD and CD are same, obviously the total side BC is getting bisected. Okay. So this by CPCT, we have written that and hence proved. Part 1, hence AD bisect BC. Now, what about part 2, which says AD bisect angle A? Okay, angle A is getting bisected. That means this green angle must be equals to that green angle. Then and only then we can say angle A is getting bisected. So let's see the congruency which we have already proved. Is it giving us that this angle BAD is equals to CAD? Let's see. BAD, this angle A is equals to that angle A. And yes, we can write from here that angle BAD is equals to angle CAD. Again, by CPCT. And hence, we are done with the second part proof also. That is, angle A is getting bisected. So we can write hence AD bisect angle A. That's it. Okay. Is it clear to everyone?
Yes, ma'am.
Yes, ma'am.
Let's do the next one. Today we'll be finishing this topic. The next one is number 3, where we are having one of the triangle like this. The figure is already given, and one of the triangle like this. A, B, C, here M, P, Q, R, and here N. And it says that two sides AB and BC and median AM of one of the triangle ABC are equals to PQQR and median PN. So let me mark it. This one is same as this one. This one is same as this one. That is already mentioned in the figure, and the question statement also says the same. This one. Okay, these are same with each other. Now show that, we have to show that first part, triangle ABM is congruent with triangle PQN, and the next part, triangle ABC is congruent with triangle PQR. Yeah, I was talking about when altitude is given, then it will be making 90 degree, and when median is given, that median will just divide the other side into equal part. That's the meaning of median. Okay, so these are the two things which I wanted to discuss with you. So here it's given that AB is equals to PQ. It's already given that AM is equals to PN, and it's also given that BM is equals to QN. Okay, now we have to show that ABM triangle is congruent with PQN triangle. So obviously these two are congruent. Can you see side congruency rule? Triangle ABM and triangle PQN. Can you see it? Do I need to mention what information we are having? Can you see all the information already we are having? Everyone?
Yes, ma'am.
So it's already congruent with each other by side congruency rule. Okay, so we can write it here again, the same thing. Here AB is equals to PQ, AM is equals to PN, BM is equals to QN. Therefore triangle ABM and triangle PQN are congruent. Yes, Aris, are you getting by side congruency rule?
Yes, ma'am.
Now we have to prove the next part. Let's focus on the next part, which is ABC and PQR are congruent. So here first let's make the list what exactly be the corresponding side and corresponding angle. Corresponding sides are already given. We are just concerned with the corresponding angles also. So here angle A is equals to their angle P. So let me write it. Angle B A M is equals to angle Q P N. What else? Angle B over here is equals to angle Q over there. So angle ABM is equals to angle PQN. And what else? Angle M over here is equals to angle N over there. I'm just making the list. Maybe it will be helpful to prove for proving the next part. So A equals to angle P and Q. These are the information which we are having in hand from the first part. We are keeping it in hand. Let's move to the next proof. So the next proof says, show that triangle ABC, the complete triangle over here, is congruent with complete triangle over there. So what can be said? So we can say, in triangle ABC and triangle PQR, we already know that AB is equals to PQ. What else we know? We also know that, let me read it, the question. Yeah, AB and BC and median AM of one of the triangle is equals to median AM, median PN. This AM and PN are the median. That means it will just touch the midpoint of the other side, right? This AM is the median. That means BM will be equals to MC over here. That's the meaning of median of a triangle. Whenever you are dropping a median, it will touch the midpoint of the other side. Here PN is the median. Here it will touch the midpoint of the other side. That means QN must be equals to NR. Okay, this is the information which is already given in the question by in the statement only, which says that AM and PN are the median of these two triangles. So let's use it. So we know that BM is equals to, what we know, BM and QN are same. From where am I writing BM and QN? It was given already. Okay, that BM over here is equals to QN over there. Median we will be using now. Okay, till now we have not used. BM is equals to QN, that was already given. Now I want to say 2 times BM will also be equals to 2 times QN, right? While solving the equation, we can add same thing on both sides. That is allowed. Still, equality sign is valid. We can subtract same thing, same number from both sides. We are allowed to multiply same number on both sides. We are allowed to divide by same number on both sides. That is allowed while solving the equation. So we are multiplying 2 over here, 2 over there. That became 2BM, 2QN. And 2BM means total BC is equals to total QR. Is it clear to both of you? Like everybody, not both of you.
Yes, ma'am.
Okay. So we are having one of the information, this one. Another information is this one. Let's see what is the next information we are having in triangle ABC and triangle PQR. So in triangle ABC, this angle B, this one is equals to angle Q. Here we have listed down ABM is equals to PQN. Okay, I want to write this one over here. ABM PQN. That triangle, that angle name slightly I want to change. That is ABC and PQR. Rather than M and N, I want to write C and R. But the angle is still same. So I am going to write angle ABC is equals to angle PQR. So what exactly is the sequence we are getting? Let's take any one of the triangle and let's see. We have used this side, we have used this angle, and we have used this side. So can you see side angle, side is getting maintained over here? Can you see it? So I am going to write these two triangles are congruent by side angle side congruency rule. So triangle ABC is congruent with triangle PQR by side angle side congruency rule. Okay, is it clear to everyone?
Yes, ma'am.
Let's move to the next question, number 4. BE and CF are two equal altitude. Again, I'm saying altitude means 90 degree it will make. Median means it will divide the other side in two equal part. It will touch the midpoint of the other side. So BE and CF are two equal altitude of a triangle ABC. ABC, a triangle is there. A, B, C. Here it says that BE and CF. BE is the altitude. Okay, this is the altitude. And CF, CF is also an altitude. And what exactly it says? Using RHS rule, it's also written over there that using, till now we were not aware of the rules and we were searching the rule by ourselves, but it says using RHS rule, show that or prove that triangle ABC is an isosceles triangle. Okay, what we know that BE and CF are equal. It's given that BE is equals to CF in length, and we already know altitude is there, so we also know that angle CFB is equals to angle BEC is equals to 90 degree, or you can take the other side also of this angle and this angle. Anything you can write it over there. Anything can be useful. Now what we have to show that this triangle is an isosceles triangle. We know two things can be done for this triangle. Okay, the first thing is either we can prove that AB is equals to AC, then we will be able to say it's an isosceles triangle. Or if this is not possible, then we will prove that angle B is equals to angle C. Then also we can say it's an isosceles triangle. So if we want to prove AB is equals to AC, then we have to take this triangle and this triangle. These two triangles we have to take to prove that AB, because side AB is there, side AC is there. So maybe we will be able to say that after proving the congruency, we will be able to say that ABAC are corresponding part of the congruent triangle and hence will be equal. Once it's equal, then it's an isosceles. But is it possible to prove it congruency? Let's check it. So here what we already know, let me mark it in the triangle itself. We know this is 90 degree. So this angle can be used. Okay, angle is 90 over here and that is 90 over there also. So 190, 90 is common. What else? BE and CF are same. Okay, this side is also same with the other side, CF. That also we know. What else we know? Angle A is the common angle in both the triangle. So this angle is also there. So angle side, we are getting the sequence. Is there any rule which says angle side? Now only I've listed down all the rule. So yes, there is one rule. We can prove by angle side, but it says in the question itself that prove RHS. So are we getting RHS also over here? Because we are bound to use RHS. We cannot take any rule by ourselves and can prove that these two are congruent. RHS rule only we have to apply here because it's mentioned in the question itself. So let's see, RHS is getting maintained over here. I can clearly see that RHS is not getting maintained over here, because once you will take this triangle, the name of the triangle is ABE. E is 90 degree and opposite to 90 we are having AB. So hypotenuse we cannot say it's same. Okay, that's what we need to prove it. So this this approach is not working for us. Is it clear to everyone? We are able to prove that these two triangles are congruent, but not by RHS. Is it getting clear to everyone why we are going to leave this rule and we are going to think about other approach?
Yes, ma'am.
So let's talk about other approach. What can be the other approach to prove this two triangle as a congruent? I said to you, either we will prove AB is equals to AC, or we will completely focus on angle B and angle C. So if I wanna focus on angle B and C now, because my first approach just failed. Let me wipe this. So we were having this way, and this way. If I have taken those triangle, that was not working over here. Let's take the other triangle where angle B must come and angle C must come. So if I am taking this triangle and I am taking this triangle, here only we have to analyze whether it's possible to prove both as a congruent or not. Then only we will go ahead. So 90 degree, our right angle is okay. Hypotenuse, here is BC and there is BC. Can you see both the triangle is having BC as a common side? And BC acts as a hypotenuse also for both the triangle, right angle triangle. Can you see? Now we need one more side same. So we already know that CF and BE are same. So yes, this is working over here. We are going to take two triangle, which is triangle BFC and triangle CEB. Okay, let's take this two triangle in triangle BFC and triangle CEB. Okay, I want to say that BF is equals to, is it CE? Okay, I have written BFC and CEB. Okay, yeah. We already know just by the given condition that BE is equals to CF. So CF from here is equals to BE from there. Is it okay? That is already given. We also know that side BC is a common side. So let me write it here. BC and BC is the common side. And what else we know? 90 degree we know. So let's write it that angle CFB is equals to angle BEC. Okay, both are 90 degree. Now, by RHS congruency rule, we can say that this triangle and that triangle are congruent with each other. Therefore, triangle BFC is congruent with triangle CEB. I told you to check the name of the triangle also, whether you are writing the name properly or not, because on the basis of that only we'll be able to say corresponding side or corresponding angle. How we'll be checking the name? Just with the help of information which we have listed down. CFBE. CFBE. Okay. BC. Yeah, I have written it properly. BC and BC. And what about angle F over here is equals to angle E over there. So yeah, angle F and angle E we have written at the same place. So name also we have written properly. From here I can say angle FBC is equals to angle ECB by CPCT. Once you have written the congruency, you have to write it by RHS congruency rule only. As mentioned in the question, you have proved it that this triangle and that triangle are congruent with each other. We have proved that angle B over there is equals to angle C over there. Okay, angle B over here is equals to angle C over there. And hence we can say, since these two angles are same, opposite side has to be same. So therefore, AB must be equals to AC, and therefore ABC is an isosceles triangle. Here we can write the converse of the theorem. If two angles are same, if two angles in a triangle are same, then opposite to those angles, whatever sides are there, those side will also be same. Okay. Therefore, ABC is an isosceles triangle. Is it clear to everyone?
Yes, ma'am.
Okay. So this is how you have to check it. We could have gone by first method only because that was working. But here that was not working according to the rule mentioned. That's why we left that approach and we just jumped to another approach. Let's do number 5 now. And then this is the last question. So ABC is an isosceles triangle. ABC is an isosceles triangle we are having. A, B, C. Where AB is equals to AC. It's given that AB is equals to AC. Draw AP perpendicular to BC. Draw AP perpendicular to BC. Okay. Here it's given that AP is perpendicular to BC. Show that angle B is equals to angle C. We have to show that angle B and angle C are same. Again, if you will look at the pattern, let's see which approach will work over here. So we already know that AB is equals to AC. This side can be used. We also know this is 90 degrees. So this right angle can also be used. Okay, so opposite to right angle, this is not just a side, this is hypotenuse. Can be used. And this side can be used. So again, by RHS, can you see? We can prove that triangle ABP is equals to, is congruent with triangle ACP. Can you see it?
Yes, ma'am.
Let's write it down. And once we will say that these two are same, then we will be able to say that angle B over here, this angle B must be equals to that angle C. So do this one by yourself. You will be able to do. By RHS congruency, this triangle, that triangle are congruent. And hence, by CPCT, angle B over there is equals to angle C over there. That's what we have to prove it. Let me check angle B and angle C only, no? Yeah, that's it. Okay. So this one you will be able to do by yourself. Now we are done with the third exercise also. Everything about congruency we have discussed in detail over here. Okay. If congruency was like, it seems tough to you, I believe after finishing this chapter, like once till now we are done already. So now it must be like very easy peasy, like questions must be there, right? You must be feeling that questions are now easy only. We are just having 5 rules in hand, and from there only we are applying rule, and each and every question we are doing the same thing. What's that? We are just analyzing it, that what can be done over here, which rule can be applied over here. Let's make the list, whatever information we are having, let's mark it in our triangle, and then let's say that which rule is working over here. Once we know the congruency, then by CPCT we can say the corresponding angle, corresponding side, those are same. Okay, now inequality of triangle, just a quick overview I am giving. Will this inequality, I believe it's not there in your syllabus. I'm just giving the overview of this one. What exactly does this inequality theorem say? So let's do that. In equalities in a triangle. So it says, let me check, two theorems are there. Prove and anything is not required at all. You just need to understand what exactly the theorem says, so that in future, when you will see this type of a statement, you will not get confused. So the first theorem says, if two sides of a triangle are unequal, the angle opposite to the longer side is larger. So if we are having a triangle, okay, this theorem says if we are having a triangle, and let's say you know that this ABC triangle, here AB is 5 centimeter and AC is, let's say you already know, it's 6 centimeter. Okay, then angle opposite to 5 centimeter will be smaller than angle opposite to 6 centimeter side. This will be larger. Okay, so whatever side is larger, opposite to that side, whatever angle is there, that angle will also be larger as compared to the shorter side's opposite angle. So here, since side AB, we want to say over here that side AB is smaller than side AC. So opposite to this one, angle C is there. This angle must be smaller than opposite to this one, angle B is there. This is what the theorem says. Okay, this is applicable for two sides. You can also arrange it for three sides. Suppose you are having this type of triangle and I am saying that this is 2 centimeter, this is 3 centimeter, and this is, let's say, 4 centimeter. And the name of the triangle is PQR. So according to the sides given, you can arrange the sequence of the angle also. So bigger side, opposite angle will be bigger. Smaller side, opposite angle will be smaller. That's it. So we want to say here that since PR is larger than PQ and PQ is larger than QR, according to these, I'm going to arrange the angle. So opposite to PR, we are having angle Q. Must be larger. PQ, opposite to PQ, I am having angle R. Must be larger. Opposite to QR, I am having angle P. This is what the theorem says. Are you getting it? Everyone?
Yes, ma'am.
And similarly, the converse of the theorem says that if the angles are given, then opposite to those angles, you can arrange the side. If the larger angle is there, then opposite to that angle, there will be a larger side. Obviously, till now, Pythagoras theorem, hypotenuse, we know right angle triangle. So what we say, in right angle triangle, we always say this hypotenuse is the largest side. Why? Because the angle sum property of triangle says total sum of all the three angles will be 180 degree. From this 180, this is only 90. So obviously, the side opposite to it is the largest side. That's why we treat hypotenuse as the largest side. Now, if you are thinking hypotenuse is largest, if you are not sure about that, I am saying Pythagoras theorem says that hypotenuse square is equals to base square plus height square. Obviously, it's largest. When you will be doing only a square of this one, that will give whatever result it will give. That result we will be getting once we'll be doing the square of base square and height square. Okay. So hypotenuse is the largest side. Why? Because it's opposite to the largest angle, that is 90 degree. So till now, just now, whatever we have, the theorem we have discussed, that whatever side is there, if the side is larger, then opposite to that side, angle will be larger. Similarly, the converse of the theorem is, if the angle is larger, then opposite to those angle, whatever side are coming, those side will also be larger. If the angle is teeny tiny, very smaller angle, if let's say this is 30 degree, this is 60 degree, then according to this Angle only we will be able to arrange the sides. So opposite to 30, there will be a smallest side. Opposite to 60, there will be slightly bigger. And opposite to 90, there is a hypotenuse, that is the largest one. Okay. Now let's see the last theorem, which says the sum of any two sides of a triangle is greater than the third side. So if we are having a triangle, okay, let's say 3, 4, and 5 only I'm taking triangle ABC. So here, sum of any two sides of this triangle. However, this triangle construction is not okay. We must draw a proper triangle. Maybe with this measurement, we'll be getting a right angle triangle or whatever. So the here the theorem says that sum of any two side, if you will take any two side, let's say AB plus AC, sum is 3 plus 4. That will always be greater than the third side. Always. Okay. This is valid for all the triangle. Once, if this fails, then you will not be able to construct a triangle. So this is valid for each and every triangle. If you are talking about a triangle, the way you know angle sum property says the interior angle has to be 180 degree. If it is more than 180, less than 180, then we will not be able to construct a triangle. Similarly here, if this case is not validating over there, then we will not be able to construct a triangle. You can take any two side, that is BC plus AC, that is 5 plus 4, that must be greater than the third side. Okay. And this is applicable for all the triangles. So these are the three triangle inequality theorems.